final review, question number 14. I have the triangle and I want to find the measure of the angle A. Notice immediately how we have the angle and the opposite to that angle. So we can use the law of sine in order to figure this out. Since we need an angle, I'm going to say sine angle A divided by the length of A, which is 12.3, is equal to sine 36 degrees divided by the length of the opposite side, which is 11.7. So here I'm going to multiply by 12.3 both sides of the equation. These will cancel. I will have sine A is equal to 12.3 times sine 36 degrees divided by 11.7. So sine angle A is equal to approximately 0.6179. And then angle A is the inverse sine of 0.6179. I will put this as A equals to inverse sine of the answer on my calculator. So inverse sine of the answer is going to give me A is approximately 38.16 degrees. 0.16 degrees, and I am done with that one. Question number 15. Suppose that you have a triangle, might not be a right triangle, and we have all of the sides of the triangle. We're going to use Heron's formula to find the semi-perimeter and the area. The semi-perimeter is simple. That is, you're going to add all of the lengths together and divide by 2. So I'm going to say 24 plus 20 plus 18 equals to 62 divided by 2 is equal to 31. So the semi-perimeter is equal to 31. Make sure you add first and then you divide by 2. The area of the triangle using the Heron's theorem, this is basically S in this case, is equal to, so the area using Heron's theorem is equal to S times S minus A times S minus B times S minus C. So this is equal to square root of 31 times 31 minus 24, 31 minus 20, and then 31 minus 18. So this is equal to, I'm going to plug that into my calculator. Got 176.16 approximately square units, of course, and the square units is provided there. So that is the answer for question number 15. And then question number 16. The path of a satellite orbiting the Earth causes it to pass directly over two tracking stations A and B, which are 43 kilometers apart. So this is the distance from A to B is 43 kilometers. So that is what we have first. When the satellite is on one side of the two stations, the length of the elevation at A and B are measured by 88. The angles of elevations at A and B are measured by 88 and 84.8, which are provided on the graph itself, respectively. We need to find the how far the satellite is from station A. So we need to find the length of the this side right here. So how far the satellite is from station A, and we need to find the distance or the height of the satellite above the ground. So we will do one at a time. The first step here is to find all of the angles of the triangle. So I am going to say this angle right here is equal to 180 degrees minus 88 degrees, which is 92 degrees. So this angle is 92 degrees. And that makes this angle right here is equal to 180 degrees minus 92 degrees minus 84.8. 180 minus 92 minus 84.8, which is 3.2 degrees. So this angle is 3.2 degrees. Now I have all of the angles. I can use I can use basically the law of sine in order to figure out the distance. I'm going to call this b because it's opposite to b. So I'm going to say that distance b over sine angle b, which is 84.8, is the same as or equal to distance 43 kilometers divided by sine the opposite angle, which is 3.2 degrees. So b is equal to 43, and we're going to multiply by sine 84.8, sine 84.8 times sine 84.8 divided by sine 3.2. Make sure you are in degree mode. So this is going to be basically 43 times sine 3.2. No. 43 times sine 84.8 divided by sine 3.2. That is going to give me 767.14 kilometers. That is the distance. So the distance from A is 767.14 kilometers. The highest from the ground, we're going to draw an altitude. So I'm going to draw an altitude here. And it's going to be making 90 degrees, which means B now is going to be the hypotenuse. And I know the angle 88 here degrees. So if I want to find the height h is basically relative to 88 degrees, and the hypotenuse is equal to, I can say that sine 88 degrees is equal to the opposite h over the hypotenuse, which is now b, and we computed b. So h is going to be b times sine 88 degrees, and we know b because we computed that previously. So h is equal to 767.14 times sine 88 degrees. So times sine 88 degrees, and that is going to give me the height is 68, I would say, 68 kilometers. So the height here is 766.68 kilometers. And that is rounded to 2 decimals. And then question number 17. I was given a triangle and I need to measure the side C. So I'm going to sketch the triangles here. The triangle doesn't have to be a right triangle. I'm going to name it A, B, and C. I know that side A is 2.54 and side B is 3.24 and angle C is 40.4 degrees. Since I have side and a side and the angle in between them, I am able to find side C using the law of cosine. So I'm going to say C square is equal to A square, which is 2.54 squared, plus 3.24 squared, which is B squared, minus 2 times 2.54 times 3.24 cosine the angle in between them, 40.4 degrees. I'm going to plug this into the calculator to get C squared, 4.42. And then C is the square root of 4.42, and I will put the answer there. So square root of the answer in my calculator, so I will get more accurate results. This is approximately 2.1.